Hello, and in this part we're going to create a digital asset from the crate. This digital asset or HDA can also be used in Unity or other game engines. Like you could see here that I made some crates with the HDA. Something important to know before we're going to create the HDA is if you want to separate the two pieces from each other, like I have here in Unity. If you're going to create an HDA from these nodes in the sub-level, there will be one big mesh in Unity. If you want multiple meshes in Unity, then we need to go back to the object level and we create another geometry node and we name it create part 2. If you would create an HDA from these nodes, they will now be separated in Unity. So select these nodes, you can create a subnetwork from them and then right click create digital asset and call it create generator. What you could also do is directly save this in the Unity project, like I did here in my asset folder under the create project. Because I saved it directly in the Unity project, it's easy to go from Houdini to Unity. So in this HDA menu, by default we will have all these values. So these are the values for transformation and so on. So I'm going to select them all and we're going to click invisible because I don't need to see them. I'm going to click apply. And I'm going to quickly jump in Unity and my create generator is here and I will be drag and dropping it in the Unity scene. And we can see that we have this result. You can see that everything is pink because the shader doesn't really support the HDR pipeline. And I'm going to quickly grab one of my materials so we can see this a little bit better. So we can definitely see here that we have separated objects, so I can drag them around. So this is already kind of working. First thing that I'm going to set up is that the Houdini asset is going to automatically assign a material, so I don't have to always have to look at this pink material. So go in Houdini. What we will have to do is here at the bottom you type in Unity material and then you can use this to assign a material. There is also one for Unreal. Depending on what game engine you will use, you can use one of them. So in here, you can already see that they typed in a path, so you have to type a relevant path to the material you want to use. Same for the Unreal one. So in my case, it would look something like this. Asset folder, then the create project folder, my material folder, and then I want to use base color 01. So basically, if you would jump to Unity, you just basically follow what's here in the project. So assets folder, create project, and then material folder, and then the name of the material. So if I would save this asset now and jump into Unity, then I will click rebuild. I will now have my crate. So I didn't assign it to the cube, but I'm gonna replace the cube anyway with a model. So for now I'm also going to go to the cube and I'm gonna delete it. Then I'm gonna open the window to create the properties and we're gonna make the HDA. So now we're gonna create some parameters to control in Unity. You can simply drag and drop values in the asset. Like I want to change the box size, so we can drag and drop this here. And I will call it the size of the box. Then we also want to control the amount of this. So I'm gonna first cut this out and then reference this. And I will give it a name top bottom ratio. And then apply. And this value I'm gonna put back this bounding box. I like to keep it separate so it's easy to adjust if you want to. So then I have split up my network into the create and then the top panel. So I want to create some folders for that. So bottom part and then another folder with the top part. As I mentioned before in the last video, that this part will be a multi-parameter, so it has the advantage of we can say how much I want to do this boolean. Like if I need this boolean 5 times, I can just click the button 5 times to create this boolean. So we're going to create a folder and I'm going to call it amount boolean and change the type to a multi-parameter multi-parameter block. So we have the list, the scrolling, or tabs. Depending on what you prefer to see, you can use the list, scrolling, or tabs. But I'm gonna go with the list, so it will list all the parameters under each other, and then click on apply. If I would go quickly back to my network, I have now my parameters. So we have the size that we can adjust. And then here we have the multi-parameter, so I can click this plus icon to say how many booleans I want, and then I'm going to build further here on to use these values. Give this a value so we can work with these values, because 0 means that there will no booleans. Then we go back into the network. Then what we want to do is create a for each number. So basically for each number that I've put in the amount of booleans, I want to loop in this network. Then I'm going to integrate this loop. So this node has to come here and the other one will be here at the end. And we can see that the loop is going through all of these nodes, but we have to delete this line of the copy to points, so it's only looping over these shapes. Then we go to the last node in the loop. Then in the iteration number we're going to have to type the amount of booleans. One more small thing I forgot is I didn't give this a proper name. So I'm going to go back here and I'll just call it boolean amount. So we're going to reference the channel. So we have to do this part twice, and that is because we are having multiple objects. So this means go one node back, then we are on this network, but we actually have to go one more back to have access to this layer. So if everything is correct, we should see the value 2, which is then of course the same as we did here. So right now it's only going to loop 2 times this network. So now I want to control what is happening in each loop. Let's say I want to change the thickness scale here over each loop. So I'm going to go here and I'm going to create a few floats. So I'm going to use some floats, call it, the first one I'm going to call it depth. This would then just be the depth on how far it goes in the shape. And I will also give it here a proper name, and I will be calling it boolean 1 depth. Then I'm going to create a few more. The scale area, which is the thickness scale, and also proper naming. Then I want to make a move up/down, so we can control where the shape is along the surface, and give it also a better name. Then I'm also gonna use a scale Y, so we can scale the boolean shaped along the y-axis. Then also I want to control the beveling, and copy this bevel one more time, and we need the divisions. So once you have a few parameters, you can press apply, and notice that there is now a hashtag added to the names. So this hashtag has then to be replaced with a number. So if I would for example go here in the thickness scale, and let's say I want to use the scale area value that I made, so we can see that there is scale number 1 and number 2. So we have to find a way to automatically put the 1 or the 2, because we cannot type this. So what we need to do is we need to build our own string. This is the expression you need to build your own string. So what you need is this expression, and we can use this then with our parameter we have. So for example, for the depth, this will be filled in here without the hashtag, and then the number will be coming from the for each count. So if we go here to this node, we can see that in the detail attributes it includes an iteration number, and this is the value that I need. So this part then returns the current number of the loop. And we also have to do +1 because it starts from 0. So the first loop will be called 0. So I have to add +1 because depth 0 doesn't exist. So now I'm just gonna copy paste this. Let's go here to the poly extrude, and in thickness I'm gonna copy paste this code, and I'm gonna adjust it a little bit so I know that I've called this scale area. And I'm also gonna fill in the depth, and I can see that we are working here with quite low values, so instead of replacing it fully, I'm gonna multiply these values with it. And here we're gonna use the depth. Press apply, and for the moment I'm only gonna use this one. And we can actually see that it's not really working. That is because some of the values are returning 0. So open back up the menu, and if we go to the channel tab, we can set some defaults. So for example, I can fill in 1, my scale area, I know it was around 0.7, and then here I'm going to fill in 1, also bevel amount, and divisions 1, I'm going to click apply. And going back here, we can see the shapes. If I would now quickly jump into the object, so if you press Ctrl 2, you can actually set a quick mark, and every time you press 2, you will be jumping to this view. So now we should be able to control the depth with these values. But one little mistake I made is I'm gonna temporarily also remove this part, and now we have the result that we wanted. So going back here, so if I play around with these sliders, I can create the depth of how much I want to boolean my shapes in there. I also notice that the parameter has a big range in here of values, so I'm also going to adjust that. So open back up the parameter menu, and we are going back here, and the depth should, for example, go from 1 to maybe 3, and scale area from 0 to 2.5. And this is already way nicer to control. So we can create something like this. We can also go back to the game engine and rebuild the asset. So it should look like this. I might need to add some normals in there. So it looks like this now, and here I can set also my boolean amount. And we can already see this going on, and you can see that this is working actually pretty fast in the game engine. And I can also quickly adjust the size here if I want a bigger crate. So back to Houdini then. And in here I'm going to continue with referencing the other values so we can control all these values in the game engine. And I will be using a transform, and in this transform I want to use the up or down. So I'm gonna use my move parameter. Then I'm also going to into the scale, and I have a scale Y attribute that I want to use. And then lastly we have the beveling, which I will here be multiplying. And then here we have the division amount. So going quickly back into the network here, so I can scale this up. I can also move it a bit better, and I notice that this is not that nicely to work with, so I'm gonna go in the menu and say I want to go from -4 to 4, and click apply. And then now I should be able to control this nicely. And with this we can already create some little bit more complexer shapes in there. So now I have mainly focused on these nodes, but I also of course want to use the other ones that I made. And I will be having a switch node that will switch between these versions based on what the user prefers. So I'm gonna keep my bevel underneath it, so I don't have to set up the bevel for everyone. Then I would delete this part, and I would copy paste these nodes here, And then also I want to copy paste the transform node and I want to use it here on this shape. You can also like color code some of the nodes where you fill in all the parameters. So if you press C, you have a little color menu, and let's say all these nodes here have been using a multi-parameter channel. Then I also want to create a multi-parameter from this one. So let's say we want to drag and drop this here. We're gonna create a menu out of this. So 0 means boolean from the sides. Input 1 is the bottom, and number 2 is on the corner booleans. Then press apply. This will throw a warning because we need to include this piece again. So I'm just gonna copy paste it here and then change this code to input and press apply. Then if I would jump back to my object, I see I have now a little menu here where I can say to do a boolean on the bottom or to do a corner boolean. Then I want to restore this corner piece that I made, and what I will be doing for this is I'm going to create an attribute and I'm going to call it corner piece. This will be a primitive and an integer, and the default value is 1. Then at the end of the loop I'm going to blast away based on the corner piece value. So add the corner piece equals 1, and this is a primitive, and delete non-selected. So then we have these corner pieces, and I can just use this here, and this is also now working back again, so I can plug this back in here. So one thing I have to mention is that the main boolean I use here is subtract. If you want combinations of different booleans, that will also be possible, and you could also include the boolean in a for each loop and have a multi-parameter selecting which type of boolean it is. This was then the first multi-parameter, and further we can also expose some values here of the main crate. So we have here the bevels, and this is not exclusive for the bottom part. So I'm gonna drag it here, and I'm gonna give it the value 1 here, and I'm gonna multiply by the small value. Then also the divisions, call it the bevel divisions, and press apply. Then what I just did actually here, I actually also want that here, and I'm gonna copy paste the nodes, and I'm gonna switch it out, so it also immediately works on this system as well. So going further here down, what I want to control is the inset and the amount on how far my crate is going. So I'm both gonna expose these values, and I'm gonna call this the depth of the crate, and this one the border size, and pressing apply. Then I go to this network here, and we're also gonna create here a multi-parameter, and it will basically a very similar way of how I did the first one. So I'm gonna go a little bit faster on this one. So create a for each count, put it in the system, then creating all the necessary values like the multi-parameter, amount boolean, and I'm gonna copy paste these values and place them here, and I'm gonna change this. So once that's set up, we can link all the values. So first of all, we need to give in the amount of booleans that's happening. So going back to the iterations and filling this in. Then also adding a value here. So then here we can use the same expression as we did before with a few changes, of course. So first is the new parameter name, and then we also need to use for each count number 2, which is this node. Then copy paste this expression and use it for the other nodes as well. then deleting this part again and copy paste it back here with all the values linked except for the bevel, and we're also going to use the same search system as we did in the other network, and also using the transform node again here to move the shapes up and down and so on. And I'm going to place the transform here. Then I need to reference the input menu, and we also need to go back here and change this menu to only go to 1 to 0 or 1. So we have a side boolean and we have a top boolean, and click on apply. One more thing I also could do is going back here to the transform and fill in this expression. So without this expression, you can see that the pivot point is in the middle of the world, but with this expression, pivot point is in the center of the object. So this will result in controlling, for example, the scale a little bit easier. And then I also add some color codes again. And last thing you could do here is, again, is same as the other one, is exposing the distance and the inset of the panel. Go back in the game engine, rebuild it, and we can see all the values that we can control here. We can already start building some nice crates if you want that. But the next thing that I want to do is to separate these parts like I said in the beginning. So right now this is just one big mesh. You can see that also here in hierarchy we want two individual separate meshes, so we can do something like this. So going back in Houdini, and what I want to do here is creating some attributes, and I will call this ID piece, and this is then 1 and the other one is 2, and I will be later using this attribute more, but for a moment I'm going to use it to split up the geometry. In here, create the null node, and this one is, I'm going to call it out create. So go back up to the network, and then here we go into the second part and use an object merge node. And with this object merge node, I want to reference the out create, and then here using a blast node and blast based on that attribute. So at ID, if it's 1, that part can be deleted. And I'm also going to create a null node here, call this part 2. Then actually I'm going to copy this here and paste it underneath here, and then reverse this node part 1. I can also see that my logs are not properly set up, so I'm going to copy this piece here. Then here for the log we're going to make some changes. This whole crate is then value 1, and then with the logs I made a separation between the bottom part, which is part piece 1 then, and then the part for the top crate, which is then part 2. So going back here to this result, we can see that this now is being separated, and this is then the result. Also important to know that the pivot we are having here will be the same as we will have in Unity. So this is not a nice pivot point to work with. So what we will do is use the axis align, and I'm going to place it on the grid. If you want to have a very specific pivot on the side, like here on the side, I'm going to show it in Unity quickly. So you can, for example, open the grid like this. That is also possible, and then you have to move the y-axis to minus, and then the pivot will be here. But in my case I actually want to just center it, and then when we go back here we see that the position is not correct anymore. It should be around here. What we could do is ask how big create 1 is. So create part 1, and I want to know the y max size, and we can see that's going on top, and because of this log system I have, I'm just gonna subtract some value here that will work. And then again, if your pivot would be something like this, then you would also have to use the bounding boxes to move it in this position. So you then basically do the same here as the bounding boxes, but don't ask the Y size, but ask the Z size and divide this by 2 so you can place it correctly. So then jumping back in Unity to double check this result, we can see that we have now 2 parts, and I can open the crate. One more thing we need to do here is restore back this top panel, and I will be doing this by creating an attribute and giving this panel a name and call this top piece. I'm gonna save it in primitives and give it the value 1. And this result I will be merging it with the shape that we need for the boolean. And then here I use a split. I'm going to split based on that attribute. So at top piece equals 1. Then we have this result, and invert the selection. Then I'm going to replace the wires. And then simply, if we have results, then we should see that in the merge. And it should look something like this. Then the last feature I want to add is, let's say I have a Unity cube and I want my crate to be the same size as this Unity cube. So going back here, and we go back to the top. So this is sort of like built-in cube, but I want a Unity cube, so I'm gonna use an object merge node, and in the parameter menu I'm going to expose this object. I'm gonna call it object from Unity, press accept. Then in here I'm gonna switch between these two. So I'm exposing this here and select input and menu. So 0 will be the built-in cube or shape, and then my second input is a custom shape. And then going back into Unity. So, and then this menu here pops up, and we can use this menu then to select a random object and get the information from. So in here I have a basic cube, and I put the pivot on the lowest point, so it's easy for me to change some values. Then what we could do is we can add a slot, add a selection. So add a slot will create this menu, add a selection will give you a menu and show all the objects found in the scene. You can click on the things you need and then press accept. But if you use the slot, you can drag and drop the cube in here. Then I switch from built-in cube to my custom shape. So what we can actually notice is that we will have some weird shapes going on. They kind of look nice, but that's not exactly what I wanted from my crate. Going back here in Houdini, I want to build a safe system for what just happened. And the reason why this was happening is because the Unity cube was looking like this. So it was triangulated, which conflicted with the system that I just built. An easy way to go around this is by using the bounds node here. And then you can see that there is no triangulation going on there. Rebuilding the asset now, this will give us the result that we just built. So if we would change the size of this cube, my digital asset should also update, but you can see it's not doing it real time. We can change this temporarily by going to the asset options and enable transform changes trigger cooks. So once enabled, so every time you make a little change, it's going to update the crate. But be careful when using this. Right now the crate is not a super complex object, so you can see it's actually in real time adjusting the size. And the cool thing about this is that we can quickly adjust crate sizes, and you can find the correct size for your level that you need. So that was it for this part of the tutorial. Next part we're going to go over some high poly, baking and making the materials.